So in this video we will study the strength of acids and bases. The stronger an acid, weaker its conjugate. So we have seen there are 7 strong acids, and all the strong acid have their weaker conjugate base, and conjugate base means once they dissociate into ions, and they will dissociate into hydrogen ion and their anion. So their anions are considered as a conjugate base. So this is conjugate base, and it would be weak if acid is strong and conjugate base will be weak. Weak conjugate base. And this acid is, since it is a giving proton, so we can call this Bronsted-Lowry acid. And the weaker an acid, the stronger its conjugate. So but if acid is weak, this is example of acetic acid, then its conjugate base will be strong. Strong conjugate. So let's see the another thing, one more example in case of acid base strength. So strength of acid base for the stronger base, and now this is the same pattern for the base also. If the base is strong, its conjugate acid will be weak. So usually all kinds of sodium hydroxide, first group element and second group element, which have hydroxide salts or compound, they are all considered as a strong base. Calcium hydroxide and magnesium hydroxide, so they are considered a strong base, and a strong base, they are ready to react with the hydrogen ion to make a water. And if weak base, so here basically in strong base, and this is considered, water is considered basically fairly weak acid. And if weak base is there, its conjugate acid will be strong. So strong base have weaker acid conjugate, and weak base have their acid conjugate acid strong. This weak base is a very negligible base. It's do not show any very good basicity. So this was about the acid base, and we can generalize that in any acid base reaction, equilibrium favor transfer of proton from a stronger acid to the stronger base to form a weak acid and weaker base. So what happened basically in acid base reaction, whenever acid base reaction happen, usually a strong acid and strong base react to form weak acid and weak base. For an example, SA, we can consider this as a strong acid, plus SB is a strong base, and they will form a weak acid plus weak base. For an example, we can write here HCl is a strong acid plus NaOH is strong base, and there basically it will not be equilibrium, they are 100% dissociating, so I will not write this arrow, I will show 100% like this one. It will form sodium chloride salt plus water, right? So this is the situation happen in the acid base reaction. Let's see some more detail about the series of the strong acid and strong base and their strength. So in this series you can see the red line from bottom to up. So here we have a strong acid, on the top we have a strong acid, and at the bottom we have low acidity or very weak acids are there, and this says acid strength is increasing as we go from bottom to up. On the other hand, the blue color fonts are labeled with the base, and these base are on the top is negligible basicity, then weak base, and then strong base, and from top to bottom this is the base strength increasing. So here we can see that the strong acids have their conjugate base negligible, show their negligible basicity, and weak acids their conjugate base have weak base, and the compound which have negligible acidity their conjugate base are very strong. So this is the chart how we are going to read. Basically, strong acid, weak negligible basicity, weak acids will give you weak base, and negligible acidity their conjugate base will be strong base. So one more, let's talk about one question here, that when HClO4 is a strong acid, given that HClO4 is a strong acid, how would you classify basicity? So this is a strong acid, as they have already said. So strong acid and their conjugate base will be very weak, or because once they will give proton, they will donate the proton, their conjugate base will be very weak, plus H plus ion. So this would be negligible basicity, we can say. Or very weak. Another example is, for the following proton transfer reaction, predict whether the equilibrium lies to the right or left, C product or reactant favor. So for an example here, HSO4, CO3 and SO4 minus and carbonic acid, carbonate ion. So you can think how we can solve this question. Basically, if you add one more proton on this molecule, this will become H2SO4. So by losing one proton, minus one proton, this and strong acid H2SO4 is a very strong acid, right? So here you can see H2. Okay, so here is H2SO4 is a strong acid, and its base will be negligible basicity. So this will be weak base, or it will behave like an acid. And also in this reaction, it is giving proton losing one more proton. So this is strong acid, and this HSO4 is a conjugate base, of a strong acid. So this will be weak conjugate base. So weak conjugate base is giving one more proton, and it is considered as a proton donor here. What about the CO3? If you see how the CO3 form, Basically, if we add 2 more proton on this carbonate ion, this will be H2CO3 and this will be carbonic acid. Carbonic acid is considered as a weak acid. It's not a strong acid. Where is the carbonic acid here? H3CO4 is not tested, look like, oh here, H2CO4. This is a weak acid. So weak acid, and its conjugate base is a strong base, and in this reaction basically it is accepting one proton. So this will be considered as a Louis Bronsted-Lowry base because it is accepting one proton. So this was the way you can find out where the strong acid with strong base, and what is the strength of the acid and bases.